program that does all the calculations and averaging and trending for you. You just have to calculate the cycle component, remember? And it does have cycle. You can clearly see it if we went to stat, time series, and if we go to trend analysis, it'll tell us that we have a linear cycle. We have cycle that kind of winds around the linear trend line for the day. Okay, something I don't want you to do. You see this MAPE here? I've had some students in the past that have used some of the other forecast methods, but they borrow the MAPE from trend analysis. Does that make sense? Shake your head no.
No.
It doesn't make any sense because every one of these forecast methods has its own error measures. Okay? They're not transferable. This doesn't apply. Yes?
Wait, when you talk about forecast methods, there's no one?
Forecast methods? I'll show you.
Is that
We all have different methods of doing things. And forecasting comes with data from different approaches. Okay? And the last time we had class, I showed you that there's a moving average that you can use to come up with an estimate. There's a trend that you can use to come up with an estimate. But decomposition uses a combination of both of those. Okay? That's its method. We're going to get into exponential smoothing hopefully today. I'm going to show you another way to forecast this bird with another method. By method, it's the approach, the statistical approach, mathematical approach that they use to go into the data and extract the trend, cycle, and seasonal components. Remember the systematic components? There are attempts to pull that out, okay? Do you understand what method is now? It's a different approach. I'm not saying that every method's the same, but there's one thing you can be sure of. Some methods are better at extracting that TC&S from some data than other methods are.
The six tests that we're going to run?
Huh?
You said about the six tests and all the tests that we're going to run on each area?
Yeah. You've got to run three different methods on each of the two variables. You're going to determine whether this makes a sign.
Okay.
So you see how critical this homework assignment is. You got to pick the right two variables. Because if you don't pick the right birds, you're going to be forecasting, you're going to do all this work to forecast stuff that doesn't work in regression. And then crack a company model. So it's important that you get these two variables nailed down. Okay? And that assignment comes into me, so you get your 10 points. All right. So this is what we've got in terms of a time series plot. Got trend and cycle. No seasonality, very little seasonality. We can check that, of course. You always check seasonality if you wish with the autocorrelation functions. Not defaulting the number of lags, but put 50 in. And we can rest assured that that fourth lag does not stick its head up above the average of the third and fifth correlations. You see that? Third and fifth lag correlations? It doesn't stick its head up, so there's no seasonality in this GDP information, by the way. All right. I'm going to show you how to forecast it.
Are you moving on to our fourth assignment, or
Huh?
are you moving into like our fourth assignment, or are you going over like 2 or 3?
This is for the assignment 3,
3? Okay.
and not the one that's due this weekend.
So are you repeating what we did on Monday?
Huh?
Alright, so therefore you're repeating what we did on Monday? the list.
we're gonna talk about this again on Monday. Is that what you're talking about?
Like, what we're doing today, is it what we did on Monday, or is it like a step from it?
It's the next assignment, what we're doing today. And it's assignment 3.
Okay, so what we did
That's-
on Monday is our assignment 2.
What do we have due Monday?
We did a lot of stuff. Yeah, we did like this. Those little boxes and stuff. That's what we did on Monday.
Let me look.
That's okay, you can read it.
Yes, please.
And this means redoing this on it, redo it.
Let me look.
Oh, no, we just want a clarification as to which side I went to.
Oh.
Because what if last time we did was assignment 2 and now assignment 3? Now we're doing today's assignment 3.
No, decomposition is assignment 3.
Yeah. He's already been over something.
He did smoothing on Monday, right?
He did decomposition.
You've got something that's due this Saturday, the 15th.
Yeah, you're right. She was just asking, was decomposition and exponential smoothing, is that a part of assignment 3?
Yes.
Okay.
That's not due on Monday, though.
He has due on the 22nd, I believe, of January.
Are you shaking your head? It's due this next Monday?
No, it's just like, I already have
She was
number 3
asking
down.
if the stuff we went over on Monday was stuff for assignment 3. She just wanted to make sure she didn't mix up
The
assignments.
stuff that's due on Monday?
No,
the
stuff we did on
we
Monday.
Oh, yeah. You mean, you talking about decomposition?
Yeah.
Yes.
She just wanted to make sure we were still
You
on
guys are
board
driving me
with
crazy.
assignment 3.
Yes. Assignment 3 includes decomposition, exponential smoothing,
Okay.
and ARIMA.
Oh.
3 ways to forecast each of the variables that you're determining this week.
Okay.
Okay? And you get big points for turning those forecasts in.
Yeah, I
Okay.
already have number 3 down, but I don't have number 2 yet.
All right. So I don't have to go back in and get the assignment
you wanna
list.
Go to, yeah.
If you want to go through it again,
Yeah.
we will not be upset
Let's see,
in
number
any
one.
way.
Going through assignment 3, right?
Yes.
I'm going through assignment 3, the first part.
Turn up.
Okay.
of Assignment 3. Assignment 3 has 3 parts.
Yes.
An decomposition part we're covering, exponential smoothing part that hopefully we'll get to today, and an ARIMA part that we'll have to cover next week. Okay?
That's great. That is such great clarification.
Thank you.
No, for real. Thank you. That made sense.
So, in assignment 3, when you get through with that, I want you to have the best the forecast from each of those 3 methods, and you choose the best puppy out of the litter. Okay? You got 3 puppies for X1, you got 3 puppies for X2. You pick the cutest one out, or the one that's most accurate, actually. The one that's most accurate, the one that's got the best model, most reliable model, and the one that looks the most reasonable. Okay? All right.
We're ready.
Thank goodness we're all level set. So let's finish where we were on forecasting GDP Brothers. And in order to forecast this, I'm going to show you the short way to do it. In a short way, I'm going to explain something to you. Remember I told you that you have to calculate the cycle. And you're going to use the last cycle factor at a minimum in this class, the last cycle factor, to cycle adjust the forecast. And what we're saying when we use that last cycle factor is that we don't know what the business cycle is going to do. Do you remember our discussion about naive forecasts? Remember I showed you what a naive forecast looks like? If you've been called naive before, it means that you're oblivious of your surroundings. And the forecast is basically the same. It's like you work for a TV station here in Texas that says tomorrow's going to look just like today. And by the way, the day after tomorrow is going to look just like today. And by the way, the day after that's going to look just like today. That's naivety. And what you have in terms of using that last cycle factor is a naive approach to the cycle. You don't know what the cycle's going to do. Okay? We're gonna make that assumption if you use that cycle. Yes?
Is there a way to, never mind. It's a question about my variables, but we answer it another time.
Okay. I'll be here. Let's see. Oh, so we're going to use a naive assumption for the quick, I hate to say quick and dirty, but the quick forecast method, okay? Follow along. You've got the GDP data, they've got the X data. This is X1, let's say. Go to stat, time series, follow the path down to decomposition, a horrible sounding method. Enter, in the menu, you enter the GDP and put the variable seasonal length. What is it? Quarterly data. 4. Beautiful. Leave it at multiplicative and trend plus seasonal. That's as much information as you're going to get out of this forecast. Generate the forecast. We only want to run the model one time. We're going to generate 8 forecasts, aren't you? Because you need those 8 to help you forecast company revenue. So these are 8 quarters in the future past the end of December 2017. We're going to store, this is important, store the first element, the trend line,
Seasonally adjusted data.
seasonally adjusted data, beautiful, and forecasts, excellent. Okay, there's 3 things. And I'm not going to show the residuals because the residuals are going to have, what are they going to have in them? The residuals, if I did storm, they're going to have cycle in them. Because this model just picks out seasonality and trend. Remember? Do I need to go back to that? See, trend plus seasonal, that's all the model. We're pushing it to the firewall, that's all it'll do. Select OK, and we get the stuff back. Remember the seasonal indices, they all sum to what number? Quarterly data?
4.
4, beautiful answer, excellent. Which is the highest seasonal period for GDP? It's the first quarter. The lowest is a 4. Doesn't look like there's much seasonality here. These things look approximately the same, don't they? The original data and the seasonally adjusted data is basically the same. It does have cycle. You can see this. And I guarantee you the residuals will look just like that. Okay? They'll have that same cycle pattern because we haven't done anything with cycle. So we just X out of this.
So you said if the original data and the seasonally adjusted data are the same.
The original data and the seasonally adjusted data, if they look the same, which they do here, there's no seasonality.
So is that good or bad?
To answer that question, you have to tell me whether seasonality is good or bad. GDP, the seasonality doesn't affect GDP apparently. Okay? That's not bad or good, it's just it doesn't affect it.
So if they're the same, then there's no seasonality.
Some data don't. Yes?
But that's not gonna affect like our forecast or anything, like the numbers you want them to be seasonal, or is it okay if they're unseasonal?
Do you think if I had data that didn't have seasonality in it, that I'd want it to have seasonality in the forecast? What do you think? Would I look kind of stupid if I presented this stuff in front of you and say, here's the historical data, and by the way, the new data, my forecast has seasonality? Do you think I'd look crazy?
Yes.
Yes. Yes, you don't want to have characteristics in the forecast that are not in the data. Okay? I didn't mean to. I was just being straightforward with you. This is important. That concept that he mentions is important because when we get to the next forecast method, exponential smoothing, you have to choose whether or not to use a seasonal model or a non-seasonal model. So what does that mean? You have to choose or determine whether your data, X data, is seasonal or non-seasonal. Because guess what'll happen if you choose non-seasonal data, but you have non-seasonal data, but you use a seasonal model, guess what'll happen? It'll create seasonality. You don't want that to happen. Or if you have seasonal data and you choose a non-seasonal model, it'll produce a model forecast that doesn't have seasonality. That doesn't make any sense either, does it? So you have to know what kind of characteristics the data have and pick the right model. This one's not so bad because it'll forgive you because it calculates the seasonality anyway, even if it's very small, okay? All right. So what do we need to do? Quick and dirty method. Let's get the naive, let's insert a column and put in cycle factors. CYCLE, the missing part. The C part of the trend cycle seasonality. How do you get them? Go calculator? Yeah, go ahead, tell me. Huh? Deseasonalized data divided by trend. Gives you the ratio of the data to the trend line, and if it's positive, if it's above 1, it's above the trend line, less than 1 is below the trend line. Okay? And you get all these cycle factors. You get one for each observation. Yes, sir?
Can you repeat it one more time? I'm sorry.
All right.
What's the calculator? What were the two,
Huh?
what were the two spreads you used?
First of all, when you run the data or run the model, you go to storage.
Yeah, I have all that, but I had the calculator part. What were the variables? What were the numbers you answered?
All right. This is what you want. You want a ratio between the trend and the business cycle. Okay? So what's got trend and cycle in it? The deseasonalized data. It's got trend and cycle. So if you divide the trend into the data with trend and cycle, you'll get a ratio that expresses cycle. Okay? Because 1 of that ratio, when that ratio is equal to 1, that means that the data is right on the trend line. If it's above 1, it means it's above the trend line, cycling above it. Less than 1, cycling below it. Did I answer your question?
Can you show us how you got to how to fill in cycle factors again?
Yeah.
Because I couldn't figure out how to insert a column, and then I missed it.
Well, that's what they ask over there. Let me go back and nuke the cycle factors. You guys can label a column, can't you? Lead cells, yes.
I just took a long time to insert a column. I kept messing up. I inserted a row instead of a column.
There you go. Just before if you want to insert a column, select one of the columns, and it's going to insert the column just prior to it. Okay, ready? Go into insert columns. All you do is right click it, go to insert columns, and then stick it in there. You see that?
Yeah.
Is that tough?
I got it now. I actually inserted it on the wrong side, and so I was scrambling to fix it.
It always
But I
inserts
missed
it
it.
to the left of the column you select. Okay?
Okay.
All right, let's do cycle factors again. Pay attention.
Okay.
Go to calculator. We're going to put this in the cycle factors column, which I've got up here identified. I've already pre-labeled it. And you divide the deseasonalized data that's got the cycle and trend in it by the trend line. Okay. Straight trend line. And it gives you the cycle factors. Okay? Everybody with me? Yes.
Oh, I inserted in the wrong one.
Some of my numbers are negative.
Huh?
Some of my numbers are negative.
Mine made a new column.
For the cycle factors,
Trend one, yes. It didn't insert it to the right one, but it made it so it was one, so it's so.
I don't know, like, I
have no choice over, you have to do no matter what.
So all the rest of them, all you said just the last,
We're gonna use a naive assumption, remember, relative to business cycles. We don't know where they're gonna go. So what we'll do is, say we're gonna take this forecast that we've got and we're gonna adjust it by the last known cycle factor. We go down to the end of the data series and pick the last cycle factor. See it? Control copy it. And go up to calculator. And, well, first, before we do that, just label a column over here. Sorry about that. It's called a cycle adjusted forecast. Because I'm going to have to put it, the answer to the calculation of the questions. Cycle ADJ forecast. I'm going to take this forecast value, multiply it by the constant cycle factor that we just copied. We go up to calculator. We're going to put this in the cycle adjusted forecast column. We're going to take the forecast, multiply it, that's a shift 8, that's the asterisk, by control V, the last cycle factor. Does everybody see that? So it's just a constant term. Since we don't know what the cycle is going to do, we'll just assume that that cycle is going to continue on the way it has been. And we'll select OK, and we get a cycle adjusted forecast. Okay?
Wait, what did you do in the expression again? I'm sorry.
You multiply by the last,
What did I do? You just multiply it. Go down to the cycle factors you calculated. Did you calculate cycle factors? Go down to you should have the same number I've got, by the way. Go down to the last cycle factor. And you don't know what the cycle's going to do you? So we're going to assume it's going to continue on the way it has been. Copy that. Go up to calculator. And we're going to put this in cycle adjusted forecast column. Go to the calculator and multiply the forecast we got from decomposition times the cycle factor. I don't know whether I still have it or not, but I did. See it?
Okay.
So what I'm doing is adjusting the forecast up by about 3.863%. Okay? And we get the cycle adjusted forecast, which is right over here under this column. And you can see the GDP forecast up here, can't you? See this? See, here's the blue data, the GDP data, and this green line's a trend line, and it doesn't have any seasonality, so the trend and seasonality line is all green. And the forecast is right here. You see these purple lines? Or these purple triangles? Does that look like it's a good forecast? Shake your head. No. Look, it's below the last observation. You see that? It's shifted down. So what we'd like to do is have the cycle adjust that forecast for us. Because that's a missing piece. That's why it's not blending in. So what we'll do is create a plot with the cycle adjusted forecasts. Copy that cycle adjusted forecast, control copy. Now, this is the tricky part. Insert a column, right beside GDP, and call it the decomp forecast. Okay?
Can you hold on 1 second, please? I'm trying to write the steps down.
Huh?
Do it at the same time.
Are you ready?
Decomp forecast.
Yeah, decomp forecast.
Okay.
put the forecast just past the end of the variable data, the GDP.
Which forecast?
The decomp forecast that I've copied. Remember up here, I have a cycle adjusted forecast. I'm gonna call it decomp forecast because I don't want to use the same title. But I went up here, copied the cycle adjusted forecast. That's this forecast multiplied by the cycle factor. And I created a column next to GDP. You can call it anything you want to. It's a forecast for the new forecast, right? And I copied those.
Okay.
And then I take them all the way down to the bottom of the column, just past the end of the variable that I'm forecasting. See that? And then you just control V, and it should paste all of the, you control V or paste all of that cycle adjusted forecast just below the GDP. And why do we want to put it down there? You say, you got it already in another column. Well, what we're going to do is create a plot, right? And the plot's going to plot the GDP, and then it's going to plot decomposition forecast, but it has missing values, so it's not going to plot anything for it until it gets to the values that we've got. So, we're going to trick the plotting. Stat time series plot. We're going to plot multiple columns of data, which include the GDP and the decomp forecast, and this is what we get.
Where did you just?
Huh? You want me to do it again?
Yes, please.
You take the forecast that you've got out of Minitab, and you copy the last cycle factor. You take that forecast that you've got out of Minitab and label another column. I call it cycle adjusted forecast. And you multiply that forecast by the cycle factor at 1.038 something, right? Whatever that cycle factor was. And that cycle adjusts the forecast. And then I paste that, copy that cycle adjusted forecast and put it just down below the end of the variable that I'm forecasting, that's GDP. Just go down below the end of it. In the first open space at decomp forecast, I paste the forecast. Okay? Is everybody with me?
Yes.
And we get, when I do that, I get a forecast that, what I did with it now, I'll do it again. Go to stat, time series plot, multiple, GDP, decomp forecast. And which forecast looks the best? Betwixt the two. Shrink this one down just a tad. Which one do you believe in? Which one looks better? The decomp forecast, see the GDP? Looks reasonable, doesn't it? Yes?
Okay, so C2 is the company you gave us, correct? That's
The-
the variable we're using for all this.
What?
C2 is the company you gave us, right? The one, like I got Merrick. That's the variable I'm gonna use like throughout the whole.
Whole class.
Okay, making sure because that's the number I use and mine just looks really ugly with everything. Like surprisingly, it just looks really bad with everything. It doesn't even look good.
Well, you know, you can square and take square root of those variables too, so you can play with them a little bit. Get something close and try squaring and square rooting them, okay? Yeah, all of these companies are different relative to the variables that will work with them. Yeah, your problem, remember I told you that you're hired by that company, which company is it? Merrick? You're hired by Merrick create a strategic plan. It begins with this forecast, this performance forecast. So you guys stick with it and try to find variables that work. Okay?
So my question, you did this to make it look better, right?
Did I do it to make it look better? It looks better because I put cycle in. Remember, the data has trend, cycle, and seasonality. The forecast that we get out of decomposition only has trend and seasonality. So I put cycle in. It's just not to make it look better, it's to introduce cycle into it. But, by the way, it does shift it up. to make it look better. The same cycle factor that was here, right? That last cycle factor is also in this forecast.
So, okay, I'm still confused on how do you tell a bad forecast from a good forecast? Like, why, so like here, would you choose the left one or the right one?
Well, which one would you like to get up and explain to your boss?
I don't know because I
The
don't.
one that has, it going further than what it was before.
You don't want to try to explain this, do you?
Okay, so you always want to use that one.
Yeah. Yeah, that's the
Oh, then I use 14.
decomposition forecast.
My columns aren't filled.
You don't want to explain something to your boss that's got a big gap in it. You'd be tap dancing up here for no reason.
Oh,
Don't, I didn't use the
so
word
I
tap
was supposed to use my
dancing.
other column.
Yeah, so if you're doing it in order, it's in order okay, so when you're selling your company, you put your forecast on your trend chart. And it's supposed to be like.
And I showed you last time how you could use the cycle factors. Use the time series plot of the cycle factors. Remember, they look like,
So like, if you look up there, it's like in the order you put them. So next to my trend one, I made a column, like a 3-column.
and you
then
see this time series plot of the cycle factors, right?
Between primary and trend one.
You could use other cycle factors if you wanted to. If I wanted to forecast a recession, I could use these, or forecast a continued little uptick, I could use these. So you can substitute some history for the cycle factors. I'd have to pick 8 of them. And they should start basically where my last observation leaves off. So I could pick these 8, okay, going forward, or I could use a recession. Yes.
Can you look at mine though, because my blue one on the first one that we did, like when I went to predict it, I don't know if it was better, because this one has a gap, but it was above anyway. You know what I'm saying? So like my forecast is already above the
What is GBNN?
government consumption expenditure in millions of dollars.
Okay. So you got a gap.
Right.
And you adjusted it, right, with a cycle factor and
This
it's got
one?
the one on the left.
This one? Yeah.
Well, that's the forecast. And the adjusted forecast values are should be the.
So you never use this one?
No, you don't want to use something that doesn't have cycle. It's only got trend and seasonality.
Okay, okay.
So leaving out the cycle.
So never use that one.
Exactly, right on.
Perfect.
Yeah, see those, you could use those cycle factors, or you could use and you pick 8 of them and multiply that whole column, selected cycle factors by the forecast. And it'll just, or use the last cycle factor.
The cycle factors that we got from there, telling you that
All right.
But I did it pretty much for some.
Does everybody know how to do this? Everybody's got this down? Okay, as I was telling you before, this is used by economists. It used to be used by economists where they go and borrow some history and put the history in as a separate column as selected cycle factors and say, hey, this is what the economy is going to do. It's going to repeat what happened back in 2007, for instance. Yes?
I have a question with my numbers. Just with my numbers,
did everything up to that point, but I
Yeah,
don't know.
cycle factor came from multiplying decomposition times trim one, and that's how we got our cycle factor. And then to get the cyclosis factor, we multiplied the last number of the cycle factor by forecast delay, and that became our cycle adjusted forecast. And then we just got our cycle adjusted forecast, and it's exactly the same as the decomposition forecast, except we put it all the way down here.
I did
So all that
everything you
is-
did, I just wanna see how you
I have no idea.
I need your opinion.
Run the correlations of both positive. They're basic statistical
So
correlations.
where were you saying the time period was the cycle factor?
I don't know.
Okay, I don't know if you can that this year.
All of age, life.
I don't know.
She's like,
That's it. Yeah, just keep in mind those numbers that you're gonna use in the adjusted forecast column, and use those later. Choose that model, or the method, excuse me, for forecasting whatever variable. Make sure you save that column. Okay? So that's how decomposition works. It decomposes the data into the autoregressive trend, cycle, and seasonality functions. And it puts those things together in a multiplicative fashion, T times S times C. And what you have to do is calculate the C, or get the C, and adjust the forecast with that C. Okay? Now I'm going to use another model. And you can see that the MAPE is 3. You see that? See this MAPE, mean absolute percentage error? And if I took the square root of the MSD, I would get something called RMSE. That's root mean squared error. And that is a unit error. In fact, let me do that.
What are you doing right now?
Getting an error measure called RMSE for this model. RMSE, come on. Since it gave me MSD is 109,035, I would go up to calculator and find the RMSE column that I've got. That's where I want to put the answer. And then take the square root, SQRT, where I can find the square root function down here, of that number, 109,035.
Where did you get your 109 from?
What's the number you used to call?
MSD, mean squared deviation. That is basically the same thing as mean squared error. Okay? So mean squared error is what? It's the error, remember the residuals? Okay? Can residuals take on positive or negative values? They can, can't they? Because the model can overestimate some periods and underestimate other periods, can it? Can it? So to get them all, get the residuals all positive, we square them. Okay? And to get the mean squared error, or the RMSD, mean squared deviation, they take that squared error and divide it by the number of observations. And that makes it the mean, the average squared error. For us, it's hard for an executive to say, okay, that's a squared error, so what does that mean? Because that mean relative to millions of dollars, or in this case, what is the GDP? Billions of GDP. What you do is you take the square root of that number, and it gives you the unit. You go to the top, it gives you the unit error. See that?
So you did the MAB,
MSD,
MSB.
take the square root of the MSD and it gives you the unit error. That's $330 billion, and GDP is in billions.
What if your number is like a exponent?
I mean, scientific notation?
Yes.
You know how to read that. And if you go to the scientific notation, you just move the decimal point the number of places it says the exponent is on the right-hand side. If it's positive, you move the decimal point to the right. If it's negative, you move it to the left.
What if the decimal's like what if the exponent number or whatever is like 20 something?
Is it the E value?
Yeah.
It's 820?
If it's like 20 something.
20? You move the decimal point 20 places.
Okay.
Is it positive or negative?
Positive.
Positive, you move it to the right
Negative.
20 places. Negative, to the left
Okay,
20
right,
places.
but like, do we have to put that in like word form? Like, I don't know what the 20th decimal spot
Leave it
is.
in scientific notation.
Okay.
And in fact, you can manipulate numbers in scientific notation in many tabs. The beautiful part about it. It will accept numbers in scientific notation. You can take the square root of it, square it, or whatever. All right. So we've got RMSE. Let me do MAPE. I'll do that by hand. You ready? MAPE. What is that? Go to calculator. We've already got MAPE up here as calculated at 3, but let me hand calculate it for you. It's the absolute value of the residuals, which I don't have, do I? I didn't calculate the residuals. We'll do it in the next model. I'll go ahead and run the model of the residuals.
Wait, where are we going?
Restore the residuals and not do a forecast.
So we're not doing MAPE?
Wait, are we doing MAPE or no?
Yeah, I'm doing MAPE. I've got to get the residuals in order to do it.
Okay. So how do you get there?
I'm going to do it right now. You just cool your heels. And I got residuals. You see this baby sitting over here? See the residuals? Now what I can do is calculate RMSE from the residuals. RMSE, I have to put a 2 here because I've got RMSE in. What is it? It's a calculator. I'm going to put this in RMSE too. It's residuals squared. It's residuals times residuals. Sum the squared residuals. Put a sum in front of it. And take the average of it. How many observations did we have? Do you guys remember? 108? I don't know. Let's look. I forgot to even notice. It's 112. I said 108. That's the RMSE. That's what we calculated.
So what happens if we get
Why
negative
does
numbers
this
for
happen?
Wait,
I got negative numbers for my RES I1. Is that right?
I have to take the square root this number. I did the wrong thing, I'm sorry. Scratch what I just said. Let's do make. Yeah, you were right. I was supposed to be calculating make, right?
Yeah.
Sorry about that. Go to calculator. Good. We're going to put this in make. Take the absolute value of the residuals, just select the residuals. Divide them by the original data, GDP. That gives me percent error. Sum all of the percentage errors. Divided by 112, the number of observations. Okay, let's see what it comes up to. 3. What did we get here? We got 3. Pretty close, isn't it? You see that? The make that we calculated is pretty close to the make we got up here. 3?
No, you did that way too fast, to be honest with you. I'm sorry.
Way too fast.
Yes.
Let me show you again.
Thank you.
Sleight of hand.
Yeah, no sleight of hand. I need to see the full trick breakdown by
Stat.
Okay.
Now, calculator. Here's the formula.
Make.
Make is equal to the sum of the absolute value, ABS, that's this first function, of the RMS, that shouldn't be RMSE, it should be residuals. Residuals, right? Divided by the original data series, GDP. So that sums up all, that creates a whole bunch of percentage errors, doesn't it? If I took the residuals, the error terms, and divided them by GDP, I'd get a whole bunch of errors, percentages, wouldn't I? Wouldn't you? You get one for each observation. See the residuals? If I divided those residuals for this period by GDP, I would get a percentage error, wouldn't I? Wouldn't I? Wouldn't I? Wouldn't I? Wouldn't I? So you get a whole bunch of percentages. That's what this is. And what you want to do is sum all of those and divide them by the number of observations. That gives you the average percent error.
Where do we get this observation from?
Huh?
Where is the observation number located at?
I just went down to the line, just to the index, and look. It's 112 in this case. You guys disgruntled about that? Did I follow it? Do it just too fast? Understand the concept. What is make? Mean absolute percent error. How do you get the percent? Take the absolute error term, residuals, which can be positive or negative. And when you take the absolute value, what happens to the positive and negative signs? It changes them to positive, right? So you're just doing away with the negative signs.
So that's why it doesn't matter if you get negative residuals.
Yeah, it doesn't matter. And you're dividing them by the original data, and it tells you percent error. Now what's the matter?
Okay, so you didn't store the residuals first, and then you did it real quick, and then you started another.
I want you to understand what you're doing,
Right.
not just the little formula.
Yes.
Okay?
What? The formula.
Keep the formula in your head. Okay. Look. You want to calculate percent error.
Yes.
You've got a bunch of errors. Positive and negative, right?
Yeah, well, yeah, I get, no, I
It
understand.
can be positive or negative. If you took the absolute value of them,
It
what is
changes it all to a positive. Yes.
If you divide them by the original data, it changes them to percentages. If you sum all those percentages up and divide them by the number of
Yes.
observations, you get the make. Mean absolute percentage error. You got it?
Understand that, yeah.
Okay, so you can write the formula down on a piece of paper. Or you can use a calculator.
What chapter is this?
You guys can write that formula then, can't you? Just remember that this is n. This is the end value right here. This is the variable that you've got, whatever it is. Okay? This is the X value. This is the N value, the number of observations. What's the matter? Different number? Did you use the same number to begin with? Is that GDP? You got residuals, they match the residuals I've got?
I don't know why.
Let me see, go to calculator. That should be the same.
Cause mine's
Take the absolute value of the residuals. Residuals are the same number series. And you divide them by GDP. Summed all that, it should be right.
I'll try later.
Okay. Yeah, it should equal, it should be, the MAPE should come up to what you see here.
It doesn't want to calculate.
And the RMSE, it's important, you guys wait a minute now, come on, let's get together. You only got 15 minutes. Because we're going to cover another forecast method in just a second. The RMSE is simply the squared residuals. Okay? So instead of taking the absolute value of the residuals, we're going to square them. You simply take the squared residuals RMSE2. Take the residuals times themselves. That squares them. And sum the squared residuals. It says add them up. Divide them by 12, 112, the number of observations at n. And then guess what you do? You take the square root, SQRT, of that whole mess. And that's reversing the squaring that we did. So it gets the error terms, the average error, back to the original data. Original data value. For billions, this is billions of dollars. If we're millions, it's millions. You all guys okay? Okay. And the reason why it's important in business to know these two error measures is because they're used in accounting, they're used in all business, because it tells you how much error is being generated by whoever's estimating something. Okay? I used to have 96 forecasters. They were planners, but they did nothing but forecast in the Midwest. And all of them generated their own error. Yeah, I looked at the error that they generated over time relative to RMSE and MAPE. The percentage, mean absolute percent error, and the unit error that they generated. Yes?
Is the smaller the MAPE number, the better?
Exactly. Smaller the RMSE, the better, right? Into smaller average error. Okay?
So is that the end of it?
Hmm?
Is that the end of it?
Is that what?
The end, or is it?
That's, for right now, that's error. Those two error measures you're responsible for any forecast model you develop in there. And the reason why you need to be able to calculate them by hand is because ARIMA and regression do not provide those error measures. You have to calculate them by hand. And worst of all, ARIMA and regression do not plot anything for you. So you just get forecasts, you get residuals. Okay, so you know how to manipulate this stuff. concept is keep the average error low, right? On models, keep average error low. We call that accuracy, right? The closer these are to zero, the more accurate the model. If you calculate it and make by hand, what do you have to do? You have to move the decimal place over 2 points. 2 places, right? 3%? Yeah, 3%. All right, this forecast. This forecast is the same data series with exponential smoothing. All right, exponential smoothing, the next forecast method. Here it comes.
Oh, man.
Go down to time series. Go to, does that data have seasonality in it? The GDP? We found out that it didn't because we ran decomposition, it didn't have it. We ran the ACFs, it doesn't have it. You can look at it until it doesn't. We can use something called double exponential smoothing. And the reason why it's called double exponential smoothing because it has 2 equations in it. One equation calculates trend, and the other calculates cycling. So the data can only have trend and cycle to use double exponential smoothing. If you got seasonal data, no, don't use it. Okay? But GDP only has trend cycle, so we can use the double exponential. Yes?
Okay, so if you just have cycle and trend, can you pick between double exponential smoothing Winters method or just double exponential smoothing?
Double exponential smoothing, you know,
Seasonality that you have, unless you have seasonality.
which method are you talking about?
I'm saying that if you do not have seasonality,
Yeah.
can you pick between the 2 Winters method?
No.
Okay, so you just say double
If
exponential.
you use winners,
Yeah.
it's going to create seasonality.
Okay.
It's going to, so you use some of the variation in the data to create seasonality, and you'd be standing up there with the seasonal forecast for non-seasonal data. Doesn't make any sense. So make sure that you pick the right model that fits the data characteristics. Does that make sense? What was that one?
The one we just finished was
So
Winters.
if we have seasonality, what do we
Yeah.
do?
Winners. Cover that next thing. Okay? Double exponential smoothing. I'm going to show you how easy it is to do it. You ready?
So is this a new lesson?
What?
Is this a new
I
lesson?
went on my own.
Yes, this is.
Is what?
It's a new lesson, right?
Yeah, it's a new method.
Okay.
We're switching.
I think this whole thing is.
No, okay.
You're switching from decomposition, which you have to forecast every variable with, the 2 variables, to another method called exponential smoothing.
Right.
And since this data, these data do not have seasonality, there's only one model that you should use. Double exponential smoothing for trend cycle. Okay?
So just to be clear, since it's no seasonality, we use double exponential smoothing. If it has seasonality, we'll do the method that we're going to do
Winners.
next.
We're going to do the next time we meet.
Thank you. Writing this down. You are great.
It's another method. We could do another decomposition model, but I'm kind of tired of doing it. I'd rather go to something else. So we go to double exponential smoothing. You put the original variable in, GDP. Choose optimal ARIMA. You see that? Because it sets the smoothing constants for the trend and cycle. It optimally sets them, so you don't have to touch them. Generate forecasts. How many forecasts do we need? 8. Storage. For residuals and forecasts. Okay? That's all I want you to do. And you press the button, press another button, and this is what you get. See the little green forecast sticking out here? See it? And it's got confidence intervals around it. We'll discuss that later. But exponential smoothing, double exponential smoothing, basically covered up most of the blue observations, didn't it? Covered them up so well you can barely see them. And it also produced 0.44% MAPE, percentage error. Is that high or low? Low. That's where we wanted to be, right? And take the square root of this and you get RMSE, 5651. If you took the square root of that, you get the unit error. Okay? So it seems to be pretty accurate. If you wanted to plot the forecast from this model, what do? You know, you've got a plot of it already, but you can just copy this and put it over here next to it. Let's open a column up just ahead of, just behind the decomp forecast. Call this Expo forecast. Okay? And take these forecast values, copy them, and get all of them. Yeah. Take those little forecast values and put them just behind the actual GDP data. Come on.
What numbers are you moving over?
Huh?
What numbers are you moving over?
I'm using the new forecast we developed with double exponential smoothing. See that? I didn't have to adjust it for cycle or anything else. I just took the numbers in the can. The data in, the can produces a forecast. Let's look at this forecast for exponential smoothing relative to GDP. Multiple columns, GDP, Expo forecast. There it is. Canned routine. Can't go wrong. Which do you like best? That? Or this? You like the left one, huh? Well, that's good because you have to make a choice. And you're choosing now by looking at these plots on the basis of reasonableness, okay? What you think is reasonable. So this, if you like the one on the left, you think this is more reasonable than this. This kind of flattens out. It's got a little cycle effect in it. It flattens it out. Is that a very difficult method to use?
For me personally, yeah.
Data in, forecast out.
I feel like at this point everything's just going over my head.
Why is it going over your head?
Everything goes so fast.
It is going fast. We'll cover it again. I'll cover it until you guys get sick of hearing it. Okay?
I lost you after you started doing the second test.
Now, the important thing is get the two variables nailed down so you can do this stuff with them. Okay?
Hey, can somebody at the front start a sign-in sheet so we can get in?
I didn't start one. You want me to?
Yeah, I'm fine.
You will?
Thank you.
Thank you for reminding us. So, There's something else we need to look at too. Remember we saved the residuals for this model?
Okay.
Stat, time series, autocorrelation functions for the residuals. Let's look at the autocorrelation functions for these residuals from. Are these residuals significant? What do you see in them? You see a little bit of cycle? See a little wave action going on in them? You see it? Look at the 12th lag period. See the 9.66? Is it significant? It's below 21, right? And the 24th lag period is below 36.4. So it didn't leave any significant trend cycle or seasonality behind. It didn't have seasonality to begin with. This model's got, it's fairly accurate. It's got 0.44% mate, mean absolute percent error. That's very low. It's got low unit error if you took the square root of the MSD. And the residuals are not significant. They don't have any significant data in them. So this is a good model from the standpoint of accuracy, reliability, and you guys have judged you like the left model better from the standpoint of reasonableness. Okay, so we only have to cover ARIMA now for GMP, and we're through with this one. Yes? Get to me quick. You gotta get them close though.
Yeah, I just remember my dick was like way
Yeah.
I don't know.
How many variables am I trying?
I tried like 19 different ones, and none of them would get like
Well, you know, there's different combinations.
yeah.
You have to have, one of them will probably be dominant, and the other will be less dominant. How about, we'll see. What company do you have?
I'm very young.
Have a good weekend, Al.
Bye.
It's a tough one.
It's good.
But keep working on it though.
Yeah, I'm gonna
Don't
go
wait
work on after
to
this.
see me to try to solve the problem.
I was trying to find the best option and then